Hello guys, we'll be talking about Wittig reactions, which is converting aldehyde and ketones into alkenes. We discussed this reaction in the part 1, and then we discussed how ylids are formed, what are ylids, and there is a two-step process for formation of ylid, converting alkyl halide into phosphonium salt and then converting phosphonium salt into a negative and positively charged species that we call an ylid. Now we are at the third step, that's the mechanism of Wittig reaction we will be discussing in this video. And before going into mechanism, let me tell you what is ylid again. It's a species with a positive charges on with opposite charges on adjacent atoms. So you have a negative charge on carbon and the positive charge on the phosphorus atom, and this is the resonance form of this, and this carbon acts as a nucleophilic carbon which will attack on the carbonyl carbon of the aldehyde or ketone. Now let's have a look at the mechanism of this reaction. Let me full share the screen. Now this is a Wittig reaction which involves ketones or aldehyde as starting materials, as I said, and this is a ylid. This is a phosphonium based ylid, and this is formed from the alkyl halide, as I mentioned in my part 2 video. Now the negative charge on this carbon atom, as I discussed earlier, how this negative charge is generated by using a base to pick the proton, which picks proton from this CH3 unit and gets a negative charge. As you know that the carbonyl carbon of aldehyde and ketone is well-known electrophilic center. Now this negative charge attacks on this carbonyl carbon and the bond shifts in the favor of oxygen here, and then this is a bond breaking process between the bond between carbon and oxygen is broken down, and the double bond is converted into a single bond, and the oxygen gets the negative charge. That's the negative charge which is there. What happens next is this bond formation takes place. The carbon and this carbon bond is formed. So the carbonyl carbon makes bond with the ylid. That's the bond between 2 and 4. So this is carbon 2 and this is carbon 4. So the bond is formed between 2 and 4. What happens next? There's a negative charge on oxygen which can act as again as a nucleophile. So it's a step or attack of oxygen on phosphorus. It's a second step. So this negative charge attacks on phosphorus. So the next step will be the formation of a bond between oxygen and phosphorus, as you can see here. So it's a 4-member heterocyclic ring now. As you see, there are 2 heteroatoms, one is oxygen and another is phosphorus, and there are overall 4 atoms in the ring. That's why we are calling it oxophosphetane. Alright, why oxo? Because of oxygen, why phosp? Because of phosphorus, ethane for 4-member ring. And these are the 2 methyl groups which comes from this acetone molecule, as acetone was our starting material. Now this is a very key important step in this reaction mechanism. This is a cycloaddition reverse 2+2 reaction. What happens is this bond between carbon and phosphorus is weak, and it gets breakdown, and the formation of a double bond takes place between this carbon number 4 and carbon number 2, and the bond between carbon and oxygen is again a weak bond, and it breaks in the favor of phosphorus, and then we will have a double bond between phosphorus and oxygen. Alright, so these 2 phosphorus and oxygen makes double bond. That's why you have a phosphonium oxide, and this carbon number 2 and this carbon number 4 makes double bond. That's why you have an alkene now. This is how you are converting this acetone into alkene by using Wittig reaction. So you will need 2 things, any aldehyde or any ketone and an ylid. And how you can generate ylid? You can start from alkyl halides, and then you can use the phosphonium salt, and then you convert phosphonium salt into ylid, and this is the mechanism. Sorry, this is a betaine and this is oxophosphetane. So betaine is converted into oxophosphetane, and as a result you get the double bond formation from ketones and aldehydes. If you have any question regarding the mechanism, please drop down the comments in this video. Thanks for watching. Bye.